Kara, thanks for the great introduction and happy to be here. I don't have to introduce myself because Kara has done a great job regarding that. So with respect to what we are trying to do at Space Computer and the current talk is, as mentioned, from the perspective of a co-founder, how is it to bridge the world between space and Web3, where most of our current team is focusing and coming from the Web3 area. And of course, this is the part where we have a lot of expertise and currently are building the aspect of how can you actually introduce this type of information to the space. And definitely it's important for us with this type of talk to also share some of the challenges and some of the opportunities we identified along the way, and hopefully maybe motivate some early co-founders along the way. Thanks a lot for having us. As mentioned, we recently announced our seed round, so we are also excited about it, and definitely year 2026 will be very busy for us as a space computer moving forward as we are. So without further ado, let's dive into the details. So as we have heard several times today, space is open for business than more than ever before. And definitely this is the part where when we started to build a space computer around the year 2024, we started to see that the meta is definitely brewing and more opportunities with respect to compute, communication, will be shifted towards space. Where of course the enabling technology coming is that the aspect that the cost of launching are becoming more affordable and make the solution much more commoditized with respect to sending and building solutions in space. Whereas we try to position as a space computer is the focused on aspects of confidential computing, where of course we know that security plays and will play, especially in the future, more and more crucial role with respect to providing compute that is on the edge, but the compute nodes where the current model where we see that most of the times the one that is actually launching your infrastructure is also usually owning it. In the future, we will see that the compute will be used and provided by certain party, and third party will be actually owning the infrastructure. This is basically where we see that it's important to provide additional security to the users. This is of course relevant not only for edge computing, but the general aspect once you consider sensitive computations, either for AI algorithms, storing your sensitive keys that will be allowing to communicate between different AI models. And this is of course very important for the sectors where such sensitivity matters. And more this will be becoming prominent as we start to shift more towards automation happening in space. And of course, what is I think very exciting for us that we are, as of now, focusing on the application of how to strengthen some of the security assumptions for solutions on Earth. But definitely in the future, there'll be more and more space-native application and solutions that actually require additional security guarantees where we want to position ourselves. The state of the space is very promising with respect to the outlines we have seen and heard today several times that data centers are definitely a hot topic, but definitely agree with Ruben that the current state of affairs is more comparable to what we see in the 90s with respect to the solutions that even though the future is bright, we actually are currently experiencing many of the challenges along the way, both on the compute and of course on the communications. It is actually something that we are definitely in early stage of how the industry develops, and it's actually something very exciting because we see a lot of opportunities and can contribute to some of the fundamental aspects of technologies and help to shape how the overall industry is going to evolve. As an example, something that is very common when we are connecting to any type of infrastructure on Earth is usually end-to-end encrypted. Current solution with respect to satellites recently shown that around only 50% of the satellite traffic is actually encrypted, meaning actually many of the data that are being sent over are plain text, and anyone can actually read what is happening under the hood if you have the right equipment, of course. So with respect to that, also we are building some of the fundamental technologies as a part of Space Computer, where we follow the story of crawl before you walk and walk before you run, because definitely something I'll be also talking about in the upcoming slides, and we have heard it several times, the timeframes with respect to navigating the space industry is definitely something that is usually done in a long-term fashion as well. We have heard a great comment from Frank at the beginning that space is quite adversarial. Definitely agree on that front. And this is actually the part we rather try to leverage to our advantage when building space computer, which is the power of the physical isolation, where this can actually provide very unique capabilities which are beyond borders, beyond reach, and are actually immune to physical tampering, which actually can provide a very unique capabilities when you're building confidential computing or sensitive layer as a part of your solution. And that part, we definitely foresee that the necessary layer that will be needed for the application and compute layer can be focusing on space native systems, where we are focusing on the aspects of the evolution of space that are being compute driven. And we definitely want to focus on the execution, trust, and settlement that is cannot be remained earthbound, but definitely focus on the space solutions as well. So with that, I really wanted to introduce where we are as a space computer before we actually start to dive into the details of our experience with fundraising before, to make a full story with respect to where we are and try to also navigate the space, which might be very interesting for hopefully many of you. So especially when we are entering the two industries, which to be fair in many aspects is a huge privilege because we can learn from aspects of what is happening in space. We can also learn what is happening in Web3 and actually try to find and bridge the common understanding. And definitely there is also many challenges with respect to the typical culture shock, like if you experience it during traveling to different countries. So this was actually in some aspects very similar because from Web3 you are very much used to have a software first solutions where actually you are like building up the software. You have very fast cycles, whereas in the space, it's usually very heavily focused on building up the hardware, which of course is kind of coming along the line that space industry is in general a bit more risk cautious with respect to some of the consideration and very definitive calculating what can happen. Whereas in Web3, you usually tend to move rather fast and break things. In both cases, actually, failure is catastrophic when you look in the space. And Web3, of course, depending on which is the stage of the project, if you consider before you can actually reach the mainnet, the failure itself is iterative and you can learn from that, which is something that usually you don't have the luxury if you look into the space industry. Look into the aspect what I think is very important as well is the general mindset that in Web3, usually you are talking about trust being aggressive and you try to build by default a system that is resistant to any type of centralized entity. Whereas in the space industry in general, we have a more trust in the institutions. And what is, I think, very interesting is also, of course, for us is the timeline that if we want to build up a compute constellation as we are trying to do, the time actually it takes to make sure that it's possible is definitely not measured in weeks, not even months, but it's usually coming in the order of years because just it takes time to build the infrastructure, build the satellites, boot the slots, and make sure that they are able to run. Which of course is very different to our experience that we are seeing in the Web3, where you can at any point in time deploy additional compute nodes on Earth and make sure so you can run your software and scale the deployments to many other people as well. Which of course come with it also the aspects that during the raising we were experiencing different type of questions. So we have heard several times that there was quite a lot of support coming from governments with respect to space, which is also one of the motivational questions we are often asked actually during the fundraisers, like where do you actually operate from? Which of course is very crucial because you can then have access to additional funding opportunities. And of course, something that is also quite interesting that the talent with respect to space is definitely something that is not fully distributed, but it's usually located in certain areas. Other part that is definitely very important for us, and this is actually something is that what happens if certain stuff fails along the way, which is something that we have to definitely incorporate into our mindset and design. And of course, since we are focusing on computing space, we are in general very much power constrained. And this is something that always was the question, like how much power do you actually need to operate your solution as well. Whereas on the Web3 side, we definitely always see the questions coming. Where is the token going to be launched? How fast can it scale? And what is the network effect? And who are the developers that will be building on top of your platform and your solutions you want to build? So definitely different angles to navigate, but with respect to that, we try to look into possible synergies and make sure that we can navigate the solutions in a better way. And actually, we managed to identify common ground where definitely what is very crucial for us is that both camps are definitely on the frontier of technology with respect to focusing on deep tech topics. And this was the common pattern that we definitely are leveraging with respect to identifying the right partners that are willing to take the difficult work with us. And the passion for deep tech is definitely something that we have in common. As we have also heard in the previous discussions, it's very important that we are focusing on what can happen, and the markets have huge potential with respect to building up an interesting technology as well. Something that we definitely also see is that usually if you are building Web3 infrastructure in some context, you actually have the access to the binary, but your solution should be deployed by hundreds or thousands of people in the wild, and they don't actually, you don't, as an owner of the or the developer of the code, don't always have access to the large scale system because it's very hard to debug and intercept and communicate with so many large scale systems where you don't have physical access to the infrastructure itself. For both cases, in case you fail along the way, it can be very much painful if you consider space. If you make certain software or hardware issues, the failures can cost you complete, for example, losing the access to the infrastructure, which is similar actually if you look in the blockchain space. If you look at some of the attacks, if you make some vulnerabilities in your smart contracts, it definitely can cost you a lot. And something that is actually interesting is the way on how some form of like a distrust is handled across participants. Whereas in the Web3 space, we always focus on the application layer, having adversaries to make sure we are building robust systems. In the space, it doesn't necessarily mean as much as an adversarial setting, but it's more like about alignment with respect to the different parties on the goals that you have. And for definitely, we see that there's a lot of tendency to make sure that you engineer your system properly to provide detailed specification on what you are building for, which of course is kind of bound to the aspect that you want to make sure that your solutions are built in such a way that actually they can last and operate in a much longer fashion and navigate in a space where actually you can have different type of changing incentives of the system along the way as well. So we see commonalities that both satellites and smart contracts can fail for different reasons, but when they fail, in the same way, it's happening in actually in similar fashion because both of these happen in a far away environment. It happens publicly because if you have some vulnerability in a smart contract, as we know, it usually makes the headlines quite easily because you're usually talking about significant money being lost because your infrastructure itself is locking quite significant funds. And unfortunately, many times the funds are lost irreversibly, and it's very hard to come back to them. So this is actually something that we see common in both of these spaces, which of course puts a lot of pressure on us with respect to making sure that our technology is sound with respect to what we want to build. And this is a part of our internal team philosophy to make sure actually we are aware of that. Which is something I'll be talking a bit more in detail on the aspect, which is the motivational factor of how our one stack emerged. So we try to take the aspects from both of the worlds, which is combining software solutions with hardware that actually can provide very unique capabilities, as you'll be describing in a soon to be published white paper as well, where actually enabling these solutions help us to co-design a perfect match between those two components and make sure we can actually leverage the best out of both of these solutions, which is something very crucial because anything that you launch in space will be running there for the lifetime of the device itself. You cannot really upgrade it, you cannot really maintain it, and it's actually important that the amount of funding that actually you put into building something can be leveraged properly and you can extract the most possible value out of the solutions you have available there. For which the generalizing approach we try to make sure that is actually also relevant for the conventional computing in general is you try to minimize your software in the sense of lowering the trusted compute base and make sure actually it's also verifiable by other parties. And as a part of the philosophy, we have to make sure that actually we are building a system that is assuming delays. It's not always possible to be able to communicate with your infrastructure because it's just not within reach of certain ground stations. It's isolated. It will be running autonomously pretty much for quite an extended period of time. And you cannot go and easily maintain it, upgrade it, or do anything to it. So you have to really make sure that your pipeline along the way is very robust. And you can consider, especially if we talk about the future aspects of environment you are navigating in is very adversarial. It's in the future, so it's going to happen that eventually you will not be owning the infrastructure, which you want to provide ideally, but also you'll be deploying on ideally third-party infrastructure that you don't own and cannot operate, and you have to be prepared that your software stack can be challenged in this way as well. So this stack necessarily doesn't belong to either of the other aspects, but it's an environment where trust is expensive, and we have to make sure that the space actually where we navigate is the first hard case actually where we have to explore and make sure that our stack can shine and develop and be developed in such a way to provide and minimize the type of challenges we are facing along the way. So moving forward, we definitely see that space will be becoming more software defined. The critical infrastructure, as we have heard, for certain reasons due to power and others, is shifting more towards space. But of course, the other aspect is that more and more compute will be happening in space, but of course, more of general activities with respect to moon exploration and others will be happening in space. And that's definitely something where we want to position ourselves, like providing a secure computational layer for other use cases. Is of course among the use cases we have heard AI, defense, sovereign compute that will be providing and sharing certain aspects of constraints that we have to navigate in. And definitely as a part of the added value, we know that security will play a crucial role. Moving forward, either we talk about verifiable AI and other type of deep tech solutions covering cryptographic primitives that can be combined together with the hardware software co-design as well. So the overall approach is actually we did both of these calculators those are the same lesson, just from different directions, that we have to be designing for various failure modes. Either we talk about thresholds or Byzantine faults, but in general, we have to have it as a part of our DNA when building the solutions moving forward. And it's actually something hopefully motivating also for others, that the aspect of solutions you have to launch have to be definitely rigorously developed. And it's something that is very interesting from the perspective of engineering and research challenges along the way. So if you have any further questions, definitely feel free to reach out. Happy to also take your questions, and join us on our journey of space computer, building a secure layer for space compute in general. And along the way, we are also currently having a few openings. So in case you are interested, feel free to reach out as well. And happy to take any questions. Thank you very much for your attention.